So with that, it is a great honor and pleasure to introduce Martin Chavez. Martin is a Harvard alumnus, along with his siblings, his 4 siblings. He serves on the Harvard Board of Overseers, and until recently, he held the top technology job at Goldman as the Chief Information Officer. You may have noticed there have been some changes at Goldman the past few months, and he's now stepping into the CFO role, and he will be taking on that role from May. And I couldn't think of any better person to tell us from his perspective right at the top of Goldman and from his personal perch looking at and the work he's been driving on the way computers and data and services and platforms are coming together to transform the financial industry. So with that, please join me in welcoming Marty Chavez. Thank you, David.
Thank you. I'm delighted to be here. It's quite a round trip for me, and I'll talk about that just a little bit, to this particular room, actually. So I'm going to begin my story just outside this door of Science Center B, and it was 1981, and I was a kid from Albuquerque, New Mexico, and I was a computer geek, and I went to Harvard instead of MIT because I wanted to do something different from things I already knew about, math and computers, and broaden out a little bit. And so I was wandering around the Science Center, and it happened to be freshman week, and Professor Steve Harrison from the biochem department was sitting at a table just outside these doors, and he was recruiting. And he said, "Biochem wants you, young man." And I said, "I don't have any interest in biochem." And he said, "What are you interested in?" And I said, "Computers." And he said, presciently in 1981, "The future of biochemistry is computational. And so if you agree to be a biochem concentrator, I'll arrange that you only have to take 2 of the classic biochem courses, and everything else can be computer science." And I thought that was an interesting deal. Unfortunately, one of those classes was organic chemistry, which was in this room, and I was definitely not meant to be an organic chemist. So from there, I'm just going to hit some of the high points. In my 4th year at Harvard, I really came back home. I met Harry, who's here with us, and I did a coterminal master's in CS, especially with an emphasis on theory. And then I took a bunch of twists and turns. Parents wanted me to be a doctor. I went to medical school. Harry told me it would be a mistake, and he was right. I did an MD, PhD program at Stanford. And so a big moment for me was my cardiovascular physiology professor told one of his Stanford classmates, so there's this guy in my CV Phys class who isn't much interested in CV Phys or very good at it, but he is really good at computers, and you ought to talk to him. So we started a company, and this was back in the latter half of the 80s. And so I was doing that, and I finished my PhD in computer science at Stanford, and was really minding my own business. And one day I'm at the Stanford department, and there's a FedEx package in my mailbox, and I didn't feel too special because there were several clearly identical FedEx packages in other colleagues' mailboxes, one of whom shared an office with, who went on to become the CEO and founder of Netflix. He also got the same package. And the package was from Goldman Sachs, which I had really barely heard of, and I had never thought of a career in finance. And the package invited me to come out to New York for an interview. Now, I was a starving entrepreneur and grad student, dirt poor, and I thought this would be a great opportunity to take this bank for a free trip to New York and hang out with my college roommates who had mostly ended up in New York. And I remember arriving at the offices, the old offices of Goldman Sachs, and thinking, this is the fabled Goldman Sachs. This place looks like a dump. And the first question I was asked was not any kind of welcome to Goldman Sachs, but it was really, what do you want, the math quiz or the computer science quiz? And very New York kind of introduction. And I was thinking, I'm glad I didn't say it, you know, I have a PhD from Stanford in computer science, and you want me to take a quiz. But instead I thought, well, given that I have this PhD in computer science, I'll just take both your quizzes. And one thing led to another, and I've been there with a couple, with one hiatus since that time, which would have been 1993. So how did all that happen? Well, really, it was simple. Goldman had told the headhunters, make a list of entrepreneurs in Silicon Valley with PhDs in computer science from Stanford, and ship them in. And this was in 93. And I had no idea I was preparing for this career in finance, but I was an entrepreneur in Silicon Valley with a PhD from Stanford. And so I think the moral of that story is just I was busy preparing. I just had absolutely no idea what I was preparing for. The very first thing that I did at Goldman is I joined an office of three very colorful guys. I think that's the adjective I'll go for. And the one thing that we say about the four of us is don't stare too long into the blue screen. I, for whatever reason, am still around. The other three are not. And one of our ideas was, let's build some software and put all of the risk of Goldman Sachs in one place. It is a pretty simple idea, a very early version of a platform idea. And even then, Goldman is a big place, so we wanted to start really small, something we can get our arms around. And we thought, let's just put our foreign exchange trades in one place. And let's gather all the financial market data that we can relating to foreign exchange and put it in one place. And we will clean these time series and we'll deliver analytics and visualization on these time series. Now, all this seems rather obvious now, but in '93, it was not obvious. And my personal first project on my first day was, would you please write an object-oriented, transactionally protected, distributed database in C? And that seemed crazy to me even back then. I thought, well, what about Sybase or Oracle? But it is something that I started working on. And so roll forward many, many years, and it has been 20-some years, but now we have all of the risk of Goldman Sachs, and that goes from foreign exchange to commodities to equities to fixed income to real estate to you name it, billions of different kinds of exposures to different markets, and it's all in one place. It led to interesting career progressions. For me, I really grew up as what we call a strat, or now the rest of the world has settled on the term data scientist, a term I like much better. Strats were just people who had a math and software skill set inside one brain. We never believed at Goldman that you could have some people do math on a whiteboard and hand it over the transom to other people who would code it up. We always thought that needed to be in one place. It ended up in 2012 that I was asked to co-head our equities business, which was a big surprise to me, but it really says much more about the equities business than about me, which is that business had completely become a platform math and software business. So it made sense in the Goldman way of thinking about things to have a trading person, a sales and distribution person, and a math and software platform person co-head that business. It was a fantastic experience that I learned a lot from. Went pretty well up until a day when, due to a bug, some complicated and interesting things happen, which I won't go into in a whole lot of detail, except to say that when I was a teaching fellow for Harry about 1 million years ago, we had the liberty, when grading programs that were handed in for problem sets, we had the liberty, whenever someone had an inline constant in their program without any comment, and it was a constant other than 0, 1, or maybe 2, we had the liberty to just fail them and hand it back. Well, unfortunately, an engineer had set a price to 1 without any comment whatsoever, and through a series of misconfigurations and accidents and the sort of Jurassic Park set of things, we put in orders to buy and sell every listed option on every symbol, beginning with I, J, K, L, or M, for every maturity for $1. Which maybe the next speaker will talk about how you don't really want to do that. So then we thought, well, we can't really live this way, and I had concerns about the software for a long time, and one thing I've learned at Goldman is when you express an opinion, you better be prepared to back it up, and so I became Chief Information Officer, which I was doing for a few years. And then back a couple of months ago, Lloyd asked me how I felt about doing some CFOing. And I said, I'm not an accountant. And I also said, when I picture myself on the earnings call being grilled by investors, I don't feel happy with that image. And he said, I'll take that as a yes. And so I am the incoming CFO of Goldman Sachs. And now I'll get into the content. So to frame what we're doing here, so a couple years ago, I was coming up to Boston and to Harvard to kick off recruiting for Goldman at Harvard, and Reuters handed me really a perfect headline that very day, which was, Google is no longer cool. It's just Goldman Sachs with beanbags. And so I had a chance to think about that one a lot. And actually, Lloyd believes everyone needs a mentor, and I thought that was very sweet of him to offer to find me a mentor after doing all this stuff for a long time. And so I got an email message from Eric Schmidt. Hey, Marty, I'd like to come over to your office and introduce myself, which I thought was backwards, but he did come over, and we've been talking ever since about the similarities in the businesses. And I would like you to keep that in mind as we go through the talk. And some of the similarities are aspirational. I have to emphasize that. And some are there right now. So what is Goldman Sachs? I really like to simplify things. So here is a simple description of the Google business model. Google produces software services, and those software services aggregate the attention of billions of people, and then Google sells the attention to advertisers. Does some other things too, but that's a pretty good one-sentence description of what Google does. So what does Goldman Sachs do? Well, we are a bank holding company. That is true. I think there's a lot of mystery surrounding what Goldman Sachs does, but at a high level, it's not at all complicated. I think the mystery just comes from the fact that we don't have bank branches, and I'm going to get to that point a little bit later on. And we are a wholesale bank. That's really the easiest way to think about it. So for the most part, though this is changing, our clients are not individuals, not retail individuals, but rather wholesale. They're institutions, corporations, governments, sovereign wealth funds, pensions, hedge funds, asset managers of various kinds, and now, more recently, consumers. And so what do we do? So client has a risk they don't want, or wants a risk they don't have, and we make it happen for them. And this is just the fundamental truth of Goldman Sachs. If the clients stop calling and talking to us about risks they have but don't want, or want but don't have, then we have no business whatsoever. And so a simple algorithm that I've been using for a long time is I come to work every day and I do things that make it more interesting and inspiring for clients to come to us with their questions and challenges. And I never do anything that makes it less interesting or inspiring, because that is the whole business model. So to make this a little bit more specific, we intermediate a diverse set of risks. And I'm not going to go through all of the examples in detail, but just to give you a sense. So in many cases, we take risk. So I'll start there on the left. So big business for us is we led the initial public offering for Twilio. There are many other tech IPOs that are in the works right now, and we're underwriting many of them, and you can read about that. And so when we are underwriting an IPO, we take the risk if some of the shares don't get sold at the indicated price, and it's our problem. So that's one thing we do. The core of the business is something that I grew up in. Actually, my first job on the trading desk at Goldman was on the commodities desk. And the government of Mexico has been a client for a long time. And a large portion of the government's revenues, the government of Mexico's revenues, come from oil. And so if the price of oil drops, as it certainly has done recently, that is problematic. Now, at the same time, there are other clients, such as airlines. When the price of oil drops, they're happy. And so there's an obvious match there between people who want the price to go up and people who want the price to go down. And that seems great, but unfortunately, the problem is the format of the commodity that the airlines buy, namely jet fuel at the jet gate, is radically different from the format of the product that the government of Mexico has, which is a particular kind of crude oil called Mayan crude oil, and you cannot put Mayan crude oil into an airplane. And so you have this very complicated supply chain of refiners, some of them physical refiners and some of them financial refiners, like Goldman Sachs, that are matching up the risk. And this is a super hard problem that we've been working on for decades, because the format is so radically different, and it doesn't work like some firms that you're going to hear about later, say matching up drivers and cars, where they want the same thing. In the central case for Goldman Sachs, what they want is often very different in time and space and the details of the product, and so you need someone to intermediate between them and transmute one kinds of risk into other kinds of risk, which is capital and balance sheet intensive, and may mean that platform economics don't work quite the same way for Goldman Sachs, say, as they do for Google in the business of search. Another thing we do is we source risk. So many of our clients, for instance, would like to own shares in Uber, but Uber's shares are not at this point publicly traded, and so that's something else that we can make happen for our clients. Now, how do we do this? Well, for my troubles in my first earnings call, which was yesterday morning, the FT has a headline this morning, which is Sleek Geek. and I don't know how to take that. But I was asked a question, which is CIO to CFO seems like an odd and unusual career path, and I didn't take it personally. And I talked about how everything we do is underpinned by math and a lot of software. So this often surprises people. 1/3 of the people of Goldman Sachs are engineers, people like me, and I think many of the people in the room who are good at math and or software. In my previous role, I headed that group of people, and I would often say the reason that I got the job, I was not the best mathematician, and I was not the best software architect, but I was able to go back and forth between the two. At least that's how I think about it. And so we built this platform a long time ago for foreign exchange. We're terrible at naming things. We call it SecDB for Securities Database. And what this platform enabled us to do was see all in one place all of our risks and all the things that might possibly happen to those risks. We were early in realizing that parametric assumptions are a bad way to live, and so we do a lot of non-distributional scenario risk analysis. We calculate millions of scenarios every day, and we think about all the things that could possibly go right and all the things that could possibly go wrong. Now, of course, we can't get all of them, so we have a spanning set, and we get very worried very early on about very unlikely things that might happen in the extremely distant future. Why is it a good idea to get worried early on? Well, if you get worried early on, there's plenty of things that you can do about it, but when the bad thing has already happened, there's almost nothing you can do about it. Now, this is not prescience. One thing that you may have read about occasionally is some will say that we knew something was going to happen. And I never know anything is going to happen. I think of everything as having some probability other than 0 or 1. And what we are doing, though, is just cranking through billions of prices and millions of scenarios, and sometimes calculating a single price is itself a simulation involving millions of Monte Carlo paths, and we do this all day long on hundreds of thousands of computers in the SecDB platform, and more interestingly, more recently, we've started making this software available. The Wall Street Journal said we were giving it away for free. I never said that. But we are making it available through APIs, and I'll get into that. This platform approach, I think, while it's obvious to many of us as engineers and obvious to people in Silicon Valley, it has not been an obvious approach on Wall Street. Our competitors are generally structured in deep vertical silos. And we have a different architecture, which is we have these shallower silos that are built on top of many layers of software, technology infrastructure, cybersecurity, enterprise platforms, and increasingly client platforms. The pace of innovation in the financial industry is something that I've never seen in 25 years. There's certainly this explosion of fintech companies. Of course, I'm talking my own book here. I don't think people will ever say, honey, I'm going to get a loan from my fintech company. I think generally you get loans from banks. And I have a strong view that the fintech companies are doing things that are super interesting and innovative, and we are participating in many of them as investors, as clients. But I think fundamentally, the system needs to be regulated. I'm a big believer in that. And I think doing things in software and thinking that somehow that makes you not a bank and therefore not something that needs to be regulated is not a business model that I would pursue. The interesting thing that's happening right now, and all of you will know about this, It used to take $50 million of invested capital to bring any enterprise software company from inception to cash flow break even. And that $50 million figure was stable over decades. Starting around 2008, that $50 million number began to drop precipitously. It is now more like $3 million, and there are profound drivers of that order of magnitude change. You never find order of magnitude regime changes in finance happening that suddenly, almost never. And what are the drivers? Well, it's cloud platforms, open source, APIs, and I think if I were talking to you 5 years from now, I'd likely add distributed general ledgers, blockchain, to that list. So we are rapidly transforming the business model. If you watch movies about Wall Street, you tend to see pictures like the one on the left. The trading floor of the New York Stock Exchange. And so how do we do this? Well, for a long time, we've been building out our own hybrid cloud platform, which we call Dynamic Compute. We're building it almost entirely on open standards. And here's something that we think is incredibly important. If 2 years ago I had told you that I was lying awake at night worried that a cyber hacker would drain the account at the Federal Reserve Bank of New York of a central bank and send the money to a casino in the Philippines, you would have thought I was on the lunatic fringe. And then it actually happened. Okay, so when I think about existential risk to our reality of capitalism and Western-style liberal democracies, well, that is one of them. And we used to think of the Federal Reserve as the ultimate safe place. The best risk protection against a run on the bank is to have $226 billion of cash and securities, mostly treasuries, mostly held at the Federal Reserve or at custodian banks, and that's all great until a cyber hacker steals it. And so what we have been doing is migrating away from the illusion that because computers are enclosed in our data centers, they are somehow safe computers, and those computers out there on the web at Amazon or Microsoft Azure or Google Cloud Platform are somehow dangerous computers. Actually, I think it's the opposite. I think for AWS and Google Cloud Platform, Microsoft Azure, and others, this is the core of what they do. They get so many cyber attacks every second of every day that it's not news or even particularly interesting. And so many of our competitors had said historically, we will not use your cloud services because we're regulated entities and we're the financial system. We, on the other hand, took a different approach, and we said to AWS, we love what you're doing. It doesn't work for us. There's a very big gap. Let's close the gap through encryption and key management. And so we've worked aggressively with them on this for a long time. And now we've reached a new state of the world where our developers are indifferent as to whether a particular data and compute load will happen out at Amazon or Google, or whether they will happen in our own data centers. And we assume that all the computers are hostile. And it doesn't matter whether they're at AWS or whether they're in our own data centers. And we think this is the only way that we can begin to get even a little bit of sleep at night. Another thing that we're doing, and many firms are doing this, is we're building a data lake. For us, it's really Hadoop. It's a layer on top of Hadoop where we've built an ontological or modeling language that we call Pure, another homegrown thing that we will very likely put into open source. And the data is just exploding. We're at 13 petabytes now. The doubling time is now a year, and in this super exponential thing, the doubling time is dropping. And so we just put all the data in one place so that we can do machine learning on top of it. The other thing that's happened is API usage has exploded across the web. And I'll just give you some examples. So just in 2015, there was a 12-fold growth in that 1 year in API calls, mostly RESTful APIs. The run rate is now about 500 billion API calls a year. And for several companies, big chunks of the revenue come via the API. So for Salesforce, half of their revenue, over $2 billion, comes by API. For Expedia, it's 90% of the revenue. That's about $1 billion. eBay, 60% of the revenue, over $4 billion, is by API. Now, back to the original slide where I talked about similarities. Goldman is to risk as Google is to search. I also said that this platform model was aspirational. Here's what I mean by that. Imagine if Google had gone a slightly different route, and they said, every time somebody wants to do a search, they pick up the phone, call their Google salesperson, read the search terms over the phone to the Google salesperson, who types them into the internal Google search engine, gets the results, and then reads them back over the phone. That is not the route that Google took. Unfortunately, that's a pretty good description of how Wall Street works. Historically, the API has been human beings talking to other human beings over the telephone, and then all the tools, the content, the analytics, the internal platform is internal only. So we are shifting this radically, and we are shifting this fast. And we are packaging everything we do, and actually we're redesigning the whole company around APIs. If you're a consumer of an API, you're probably in a different division or department than the producers of the API. And this is also taking a page from the Amazon Web Services playbook. And so the API approach lets business combinations exist that wouldn't otherwise have existed. So I don't know how Netflix would have developed its streaming services without AWS. I'm sure they would have figured it out, but the fact is they sit on top of AWS. Uber, similarly, historically, sits on top of Google Maps, though there's speculation that they may be adopting a different approach. I don't know. But if Uber had to go out and digitize the planet and then get digital maps on phones and get the phones into the hands of lots and lots of consumers before Uber even had its first passenger meet its first driver, I think that would have been hard. But because all of this existed, Uber could just plug into it. If we can have the approval happen in seconds, let's do that. If we can cause the funds to be wired the same day, let's do that. And one of the things that we have been absolutely dogmatic about is it is all straight-through processing and software. There is no human intervention. There's no spreadsheets in the middle of the supply chain, which is usually the case in finance. We're evolving our interaction model. One of the things that we figured out, the whole world has figured this out, is that what really makes us valuable is the immense amount of data that we have. There's a story, maybe apocryphal, attributed to J.P. Morgan. Someone asked him, why did the market go up? And he said, because there were more buyers than sellers, I should think. Now, if you ponder that, there's always the same number of buys and sells. So what did he mean? Well, he meant more people interested in buying than interested in selling. And certainly in this job of inspiring our clients to call us because they have risks they don't want or want risks they don't have, there is incredible information content, and using that for the benefit of the clients so that they get a better result is what we're up to. And so we're turning all of the verbs, all of the activities at Goldman Sachs into APIs. One of the things we're insisting on is a very high standard of lovely and impeccable documentation for these APIs, because we are opening up the vertical monolith, which used to have only one API point, which was human beings on the phone, and now many RESTful APIs. We're turning all of our services into collections of apps. We have a few of them. Everyone who's ever been an alumnus of Goldman Sachs misses our time series, misses our visualizations and analytics. We're making that all available, again, a very high standard of UX, but if you don't like our UX, that's fine. It's all available by API. Everything that our clients do, which is to understand the risk, to measure it, to tailor it, to get from where they are to where they want, can now be done by API verbs. We are opening up other retail businesses where historically we couldn't get comfortable in going through intermediaries to retail clients because we couldn't be certain that the intermediaries were properly explaining all of the risks. But now with software, you can do this. So our new software platform has quizzes, tests, certifications, workflow, heat maps, everything entirely automated, which is letting us scale our business in ways that we've never been able to do it before. Marcus, as I mentioned, our new online consumer lending platform. I encourage you all to try it. I think it's beautiful, but obviously I would say that. And one of the things that we say in the tagline for our new consumer business is it's a fintech startup with 147 years of experience. One of the interesting things that I will say about Marcus is we went from inception, empty screen buffers, to launch, full production launch, in 12 months. And the only way you can do this is through platforms and APIs. Just about every platform. There's about 100 different platforms, many of them open source, that are part of Marcus. So we've got Elastic and Kafka, for instance, and then we've got service providers such as Twilio. FICO is now available by API, Facebook and Adobe for marketing, and all sitting on top of platforms that we've built for the years so that we can analyze the risk. And we see the whole financial business going in this direction. Around virtual machines and strong APIs, and we aim to participate at that core level of risk transfer. We'll do other things as well, because we have to, but if someone else is a better provider of services that traditionally were vertically integrated inside of Goldman, we're happy to use their service instead of our own. We just want to have choices. Now, the last slide, this is one of my favorites. So, something that's really different about what we're doing is that historically Wall Street had been seen as quite insular, and now we've gone in a very different direction. One of the best parts of my job is I look after a portfolio of about 100 investments, usually in startups. Sometimes they're startups that we helped fund. I think almost everybody in this picture, except for two people, is a Harvard alum. This is a little a company that's right next to the Smith Campus Center, and it's called Kensho. And I discovered it through my work at Harvard. I think I get back an awful lot more than I give. I was on the Dean's Advisory group for the School of Engineering, and I ran across this little company, a bunch of Harvard, some MIT engineers who were doing this incredible machine learning work, trolling the web, and similarly to what to Google does, and finding all these spreadsheets that government agencies were producing, ingesting the spreadsheets, building an ontological database of cause and effect, so you can ask Kensho questions like, when OPEC announces a production cut, or when Trump issues a tweet, what stocks go up and what stocks go down? And this is something that they are really, really good at. It's not our business. It's something our clients are super interested in. And so now what you can do is you can go to Kensho and you can get ideas for investments, and then that's something they're good at. Through an API, you can drop it into the Goldman Sachs platforms, and you can actually get that portfolio of stocks, which is something that we're good at. And so we're moving very rapidly into an ecosystem where we don't have to do everything in-house. We don't want to do everything in-house. There's a couple of things that we're really good at and lots of other things we'd rather partner with others. So I'll stop there, take a couple of questions.
Okay, so we have 2 microphones back here. If you can put your hand up, we'll run the microphone over to you.
Thanks for a great talk. I've been a systems engineer for my entire career.
But now that you have these computers and you've got microsecond latency between when you put a trade into a venue and when you get the execution back, there's an awful lot of things that can go wrong. Now, actually, where we have learned the most about how to control these complicated interactions is from, if you can believe it, the railroad industry. And so here's the idea. If you have an algo that's doing a lot of computation, one of the approaches that many thought would be sensible, and I've had some very interesting conversations with regulators on this topic, is why don't we review the algo and review documentation of the algo and give those reviews to independent control functions, and that's how we'll get comfortable that the algo is operating correctly. I actually had a meeting in London where I had the opportunity to take a bunch of regulators through a mini lecture on Turing decidability and the halting problem, and why that was not something that was going to work as well as they thought it might. And what we actually do is say, the algo can do whatever kind of computing it does, but there is a boundary around the algo where it then touches the real world or the outside world. And it's at those boundaries that we have an incredible amount of control. And so before any code can actually be released into production, we have a quite intensive set of procedures for how it must be reviewed, all of the different kinds of controls that ought to exist, and then the developers of the code actually have to assert that all those controls exist and that they are effective and produce evidence of the effectiveness before any of this code can go out into the wild. Now, again, no guarantees, but it has been our experience that when we go through this process for anything that is electronic trading, which is a very broad definition for us, we have not had any mishaps. The mishaps happened before we put this whole structure into place. Again,
I was more concerned with cataclysmic failures.
Yeah, well, so, cataclysmic failures, there's an example. It happened in August of 2012. And so, again, for the cataclysmic failures, we think that this kind of control mechanism is the one that you need to have. The problem is that you may be thinking about systemic failures. And so you might protect your own organization against these kinds of failures. But what happens if the whole industry goes into some kind of a problem? This actually happened not so long ago. It was called the cable flash crash. Cable is a term for dollar sterling. And the dollar sterling dropped from 125 to 113 in the space of seconds. Now, it happened in the thinly traded markets when New York and London were closed, and the question is how did that actually happen? And so we keep learning from these cataclysmic failures. So one of the things that we learned is that if we see a change in the price, we ought to pull out of the market, or we ought to widen our quotes or reduce the volume. And maybe this gets to your point. It's not enough to have this discipline in our own shop. It's much better if we share all of these disciplines broadly with our competitors, and if the regulators then require this kind of discipline to happen throughout the system.
So let's take one last
Yeah.
question over here if we can, and then we'll move on to the next speaker.
Hi, thank you so much for that. My name is Sandy. I'm the Director of Labs for John Hancock. I manage our AI and our blockchain teams. I was very interested in the Marcus product and how you got it from inception to full production in 12 months. How are you recruiting your team? How many of them are legacy Goldman employees versus startup entrepreneurs? And how are you incentivizing them? Because entrepreneurs have the runway that's going to run out, so they build, whereas legacy employees don't. And I think that this is a problem that companies with innovation labs and trying to build products quickly, we're all facing. So I'm just interested in the makeup of the team.
Yeah, so that's I'll give you the short form. So the first thing that we did when we launched the business is we wanted to have a lot of humility about all the things that we didn't know about. And so we were super clear, we don't know anything about retail businesses, period. And so the first step was recruiting from people who do. And so the leadership team came from Discover and a number of other firms that do know a lot about retail. So that was the first thing. But over half of the people in the Marcus business came from other parts of Goldman. And this is I hate the dress code more than anybody. I think I'm really well known for that. I'd go for shorts and flip-flops personally, but so we do have a little bit of a dress code. But one thing that we found is that engineers don't really want actually the bean bags much. They just want an environment with a lot of autonomy to make decisions.